And welcome to another Tutor Doctor Mathematics video. In today's video, we're going to be covering question 1 of the IEB May 2022 supplementary exam for matric. One thing to note about the IEB questions is that they are scaffolded or they have follow-through questions. So sometimes the answer that you find in question 1A will follow into question 1B or question 1A number 1, that answer you might use in question 1A number 2. So it's important to keep track of your answers. But when you're doing these answers and marking them by yourself, remember that there's also continuous accuracy. So if you got the previous answer incorrect, but you still use that same value and you got to a different answer in the second line, that's still okay too. So for question 1, this is all about analytical geometry. So gradients, distances, midpoint theorems, the like. That's what we're going to be focusing on in this question. I'm just going to erase this because it's covering the words. We're told that a straight line goes through 2 points, P, x is 2, y is 9, and Q, x is 6, and y is 17. So this is our 1 point P. And our second point is Q, which is 6 and 17. Question 1A, number 1, asks us to determine the gradient of PQ. We know that the gradient of a line is given by y2 minus y1 over x2 minus x1. And remember, you don't get a mark for writing out the equation. I'm just writing this out for simplicity. You get a mark for your substitution. So choose in any order. I'm going to choose 17 as my y2 and 9 as my y1. And keeping in that same order, 6 will be my x2 minus 2. 17 minus 9 gives us 8. 6 minus 2 gives us 4. And 8 over 4 is 2. So our gradient for PQ is equal to 2. So you'll get 1 mark for your substitution and another mark for your final answer. Now, we're asked if PQ and W having coordinates -6 and t, are collinear, then what is the value of t? Let's start off by defining what collinear points are. So collinear points are points that lie on the same line, on the same straight line. So this means that W, Q, and P all lie on the same line that has the same equation and the same gradient. Now, if we know that the gradient of all of these points is the same, and we're trying to find one value, we can use the same gradient formula that we used above with any of the 2 points, either P or Q, because we know both of the values for the coordinates of those points. We can find our missing value, T, which represents the y coordinate in this point. So, given that our gradient is 2 from the previous answer, I'm going to use Q. We know Q is given by 17, 6 and 17. We can substitute y2 minus y1. So I'm going to choose 17 as my y2 once again, minus y1 would be t, minus t, divided by x2 would be 6, minus 6. Now we're left with 2 is equal to 17 minus t, remains as it is, divided by 6 minus 6 gives us a positive 12. Remember that 2 is the same as 2 over 1, So through cross multiplication, we'll have 24 on the left-hand side is equal to 1 times 17 minus t, leaves us with just 17 minus t. This is 24. If we subtract 17 on both sides, 24 minus 17 leaves us with 7 is equal to minus t. And if we divide by negative 1 on both sides, t is equal to negative 7. And that's it. So t is negative 7. Question 3. In question 3, we're asked to find the equation for the perpendicular bisector of PQ. We're told in brackets that a line perpendicular to PQ that goes through the midpoint of PQ. So that's what the perpendicular bisector is. It's a line that's perpendicular. So let's break this down. A line that's perpendicular, we know, is a line that lies at 90 degrees. So it's a line that is at 90 degrees with PQ, which is the line between these 2 points that we were given earlier. That goes through the midpoint of PQ. Interesting. Remember when we were learning about analytical geometry, we learned that when two lines are perpendicular, so let's call this line AB, and let's call this other line CD. AB is perpendicular to CD. We know that when two lines are perpendicular to one another, the product of their gradient, so the gradient of AB times the gradient of CD, must always give us negative 1. So the gradient of PQ and the gradient of the perpendicular bisector must equal negative 1. So negative 1, the gradient of the bisector times the gradient of PQ. Earlier on, we were asked to find the gradient of PQ. So the gradient of PQ we know is 2. So we can just substitute that. So the gradient of the bisector, we don't know what that is. Oops. Let's remove that. Okay, everything got a little bit moved up. Let's see if we can fix that quickly. There we go. The gradient of the bisector is what we're trying to find. And the gradient of PQ we know is 2, so multiplied by 2. So to find the gradient of the bisector, we divide both sides by 2. And that leaves us with a gradient of negative a half. So this line that we don't know yet, this bisector, has a gradient of negative a half. We're also told that this line that's perpendicular to PQ goes through the midpoint of PQ. So what we can do is use our midpoint formula and find the midpoint of PQ. So our midpoint formula is M is equal to x1 plus x2 divided by 2 and y1 plus y2 divided by 2. And this will give us two coordinates. So the gradient of PQ would be, what are our values for P and Q? So 2 plus 6, those are the two x's. So this would be 2 plus 6 divided by 2. And then for the y values, that would be 9 plus 17 divided by 2. Two plus 6 gives us 8, divided by 2 is 4. 9 plus 17 gives us 26, divided by 2 is 13. So the midpoint of PQ is 4 and 13. So now we have a point. So that's one of the points on this line, on this bisector. So we can substitute the 2 points that we have, as well as the gradient that we calculated. Remember that the equation of a straight line is given by y is equal to mx plus c. We've got a y value, we've got our gradient, we've got x. All we're missing is the constant. So we can substitute 13 into y. We can substitute negative a half into m. So that's negative a half. We can substitute 4 into x plus c. So now we need to find the constant. Negative a half of 4 is negative 2. So 13 is equal to negative 2 plus c. If we add 2 to both sides, that leaves us with 15 is equal to c. Now we can just rewrite the formula. Y is equal to m is negative a half x plus 15. Oops. Let's get rid of that. Select. Sorry about that. Plus 15. And that's it for question 1A, number 3. Let's move on to number 4. If point H14 and y lies on the straight line with an equation 4y minus x is equal to 2, then what is the length of PH? Remember, this is all still in the same question with all these points P, Q, W, and the perpendicular bisector. So all of that information can still be helpful. Well, let's start off by reminding ourselves what the value of, or what the coordinates of P were. So P is 2 and 9. Let's write that in yellow. So P is 2, 9. And H, we're told, is 14 and an unknown Y value. And we're told that it lies on a straight line. So we know that the formula for a straight line is Y is equal to mx plus c. But our formula isn't written in the standard form, y is equal to mx plus c. We need to rewrite this in standard form. So let's get y alone. So this would be 4y is equal to x plus 2, or 2 plus x, doesn't really matter. If we divide both sides by 4, okay, maybe let's write the 4 properly. 4, we're left with y is equal to x over 4 can be rewritten as 1 over 4x, and 2 over 4 is just a half. That looks a little bit more like y is equal to mx. So here's our m. Our gradient is a quarter, x plus c. Now let's substitute our x coordinate in order to find our y. So y is equal to 1 over 4 times 14 plus a half. 14 divided by 4 gives us 3.5. So y is equal to 3.5 plus a half. And that gives us 4. So y is equal to 4. But we're not done yet. We've only just found the value of y. So y, we now know, is equal to 4. We're asked what is the length of pH. So in order to find the length of a line, we can use the distance formula. So the distance formula would be x2 minus x1 squared plus y2 minus y1 squared, all square rooted. So we'll have a big square root and we'll take 14 minus 2 squared plus 4, which is the y value that we just found now, minus 9, which is the y value for p, squared. Type all of this into our calculator. We find that the length of pH is 13. So the length of pH is 13. Let's go to the last part of question 1, which is part B. In the diagram below, AB has a gradient of 5, and the equation of AC is 2y minus x plus 1 is equal to 0. We're asked to calculate the size of theta, which is the angle between AB and AC. So let's write down the information that we're given here. This line AB, we're told, has a gradient of 5. And the equation of AC is given to us as 2y minus x plus 1 is equal to 0. Once again, this is a straight line. The equation of a straight line is given by y is equal to mx plus c. We need to rearrange this formula so it's in standard form. So let's get the y alone on one side. We'll have 2y is equal to negative x will become positive x, positive 1 will become negative 1 if we bring these two terms to the other side. Now to get y alone, we'll have to divide both sides by 2, and we'll be left with y is equal to x over 2 can just be written as a half x, and negative 1 over 2 is just negative a half. So the line AC is given by the equation a half x minus a half. We're asked to calculate the size of theta. Now, I want us to quickly do some revision on some grade 11 stuff. The diagram shows here that a straight line makes an angle theta with the positive x-axis. So this line makes an angle theta with the positive x-axis. So the x-axis on the right-hand side of the y-axis, similar to what we have here. We have an angle theta formed between the line AB and AC. And technically speaking, the angle also extends through here, but for us, it would be between angle AB and line AB and line AC. This is called the angle of inclination of a straight line. So since ours doesn't lie between the positive x-axis and the line AB, it wouldn't be the angle of inclination. The angle of inclination would be theta plus the smaller space, but the idea still remains the same. Here we're told that we notice that if the gradient changes, then the value of theta also changes. Therefore, the angle of inclination of a line is related to its gradient. We know that the gradient is a ratio of change in the y direction to the ratio of change in the x direction, like we were calculating earlier on. The gradient is y2 minus y1, which is also represented as a change in y, and x2 minus x1, which can also be rewritten as a change in x. From trigonometry, we know that the tangent is defined as the ratio opposite over adjacent for tan theta. Now, if we look at our diagram again, this change in y and this change in x, and if we were to draw a trigonometric triangle, we can see that the gradient is given by tan theta as long as theta lies between 0 and 180 degrees. Let's look at a more practical example here. We have a line with 2 points A, B, and we have an angle, alpha in this instance, that is 61.92 degrees. If we move this line it's not allowing me to move. Ah, okay. Okay. Let's try this again. Okay. It's not allowing me to move. But if we move this line, it's going to change the gradient, and that in turn is going to change the size of alpha or of theta. So we know that in our formula sheets, we even have this formula. So m is equal to tan theta. But this formula comes from the angle of inclination. So we're given the gradient of AB, which is 5. So the gradient 5 is equal to tan of theta. But remember, not this theta. So this is how it's written in our formula sheet. The gradient of AB is going to be equal to tan of the angle between the positive x-axis and this line. So this would be this whole angle here. So let's just call that alpha instead of theta, so we don't get anyone confused. Alpha. So 5 is equal to tan alpha. And we know if we want to get alpha alone, we can take the inverse of tan of 5. So that would be tan -1 of 5 is equal to alpha. And if we type this into our calculators, shift tan of 5 would give us 78.69 degrees. And that would be alpha. Now, how about if we want to just get this little angle alone? Because if we get the whole angle and this tiny angle, we can subtract them in order to find the value of theta. So let's call this second smaller angle, let's call it beta. Same principle applies. Beta would be the gradient of the line from which it extends m is equal to tan of beta. So the gradient of this line is AC. And we know that AC is given by the formula y is equal to 1/2 x minus a half. And our gradient here is a half. So our gradient is 0,5 or 1 over 2 is equal to tan beta. Once again, to get beta alone, we'd take tan to the power of negative 1 of a half. And we do shift tan on our calculators, and we find that beta is 26.57 degrees. So to get theta, we take 78.69 minus 26.57, because theta is the value of alpha minus the smaller value beta. And we find that theta is equal to 52.1 degrees. And that's it for question 1 of the IEB Grade 12 Supplementary Exam from 2022, covering analytical geometry.